So basically two things. So حطولنا schedule للfinal exams. Good morning, Jana. Now that we have the schedule for the final exams, I wanted to check with you if there is any common day where you all have a major exam which we should avoid for the presentations. لأنه registrar has been asking to try to finish as soon as possible grades كرمال يعني لا يعرفوا ال requirements لل graduating class إذا حدا بده شي requirement أو شي هيك. So good morning عمر. So if you all have a group where you know that there are مثلا 1 or 2 days where for sure those we should not schedule anything لحتى أقدر أعطيكم نفكر بغير options. Okay, so send me one email if you can do that. هلا منشان ال percentages كنت حاطة هيك rough sketch. I will share it with you. I was considering إنه أول شيء deliverable للproject يلي هو فيه SPICE وفيه report. It will be 10% for the SPICE experiment and 25% for the report. طبعا 25% for a very يعني for the best report, and then مش حأعطي zero للworst بس إنه the grades will range between somebody who met the minimum requirements and some report that really stood out who will take the full grade. So حيكون 35% على deliverable of next Sunday. The EEs بما إنهم 5 hopefully I will also try to give 35%, 7% each. هلا في حدا سألني إنه will we drop the lowest. I'm not sure if we can afford to drop the lowest, but what I will do, I may put slightly lower percentage على lowest حتى ما يأثر إنه إذا في حدا علامته حتتأثر إنه كتير ما يأثر عليه. بس بتصور you will all do fine and you will not need that far. For the presentation we will be left with 30%. I would like to leave it بين مثلا 15 يمكن 15% على الكويشن. ممكن أعلي عليه شوي إذا لقيت عم نسأل أكتر وعلى presentation بين 12 و 15%. يعني تقريبا quizzing to you verbally will be between 15 to 18% or 20%, and the presentation will be between 10 to 12%. يعني هيك شيء لنكفي 30% الأخرانية. هلا I had also a question where I don't know if you هلا بنبعت الدودل بس I will try to make it maybe during next week the schedule or the timing for which we will select the time to meet with you. يعني مش هالأسبوع، الأسبوع اللي بعده. Okay. طيب. Okay, so let us start with EE5. Rashid is on Wednesday, and a lot of you have the FYP report, right? أو شو؟ Okay, so is Friday better for all of you? And we can log in same time of the نفس الصف، نفس الوقت تاعون الصف، بس it will carry 7%. يعني إنه so حأبعت email إنه per your request we schedule the exam on Friday, and if somebody misses it hopefully not. يعني ما بدي أرجع أعيده مرتين أو بيكون willing to shuffle the percentage to the question that I asked them. But I prefer that we do it written so that I have a written record. Another question that I had for all of you, and if we hold the presentations over Zoom, I know that's going to be too many videos for me to be recorded, بس حتى ما حدا يرجع بعدين يقول لي إنه ما أنا جاوبتك صح وأنت قلتي لي ما بعتقد حدا منكم حيكون هيك. But just in case because you are all 70, do you mind if I record the voice just like I'm recording my voice for the oral exam question session? If you mind it, you can tell me you refrain. If you don't mind it, I will go ahead and record it. Okay, so I'm going to ask you that question just in case حدا حس إنه العلامة تاعت السؤال I was not fair in it، حتى من يعني مش حاجي حارجكن على علامتين ثلاثة، بس إنه just in case you wanted to revise what you told me. The other thing I was wondering, but I'm not sure if this is going to be a popular idea, is بدل ما أسألكن أنا سؤالين, if you would like to prepare on the part that you pick an explanation of a concept. يعني مثلا حدا بده يشرح what is Elmore delay، حدا بده يشرح something. هلا أنا I will still ask you كريم my question، لأنه فيكم تقروا شرح بعضكم وتعملوا فيديو، بس إنه just to boost the grade هيك، إنه if you prepare a 5-minute snippet and somebody prepares a Google Drive link where you would explain something, some concept that you learned, and then about that specific concept, I can ask you to repeat it for me, and then I will ask you my question. I will specify the basic concepts. هلا البيسك concepts حيكونوا لا individual، كل واحد يعمل لإله، ينقي التوبيك اللي هو كتير مرتاح فيها ويعمل لي 5-minute هيك snap shot video explaining something with your own voice. You don't have to show up in the video. You can do the same just like I explained voice over PowerPoint. تسجلون تبعتولي هن أو شيء، حدا منكم يعمل جوجل درايف نجمعهم فيها كلهم أو upload على الموديل. Yes, I'm going to ask you to explain it again in the exam if you want. إذا ما بدكم تعملوها voice over PowerPoint، بس practice it before. Pick a concept which you think that you can explain well. So I will need to send you an email about that, and then I will ask you to explain it to me. And then I will ask you another question to address a question that I have. هلا main topics which I'm going to ask you to address that I have, I will also send an email about them. بس mainly بدنا نكون familiar، قادرين نشتغل بال unified current model، familiar بال inverter VOH VOL مين on مين off هالقصص، familiar بال delay calculations والcapacitor calculations، يعني هو هن المين concepts اللي حكيناهم، Elmore delay ويولر باس. هلا اليوم حنقطع ب homework 4. So I'm going to start with a small concept, and this small concept I will carry it over to homework 4 to show you how we relate the Euler path, and then how we can briefly look at how we can study the delay within a small gate. هلا في اشياء بالchapters يعني حشوف وين بنوصل الاربع، اذا بعطيكم very basic thing about power or a hint بس هيك ما ضروري يكون داخل بالاكزام about the logical effort or the sizing which we used to cover in the previous courses, a hint about maybe past transistor logic هيك 10 minute إذا lecture Wednesday حتكون full hour I will give you half and half hour بس تكونوا أخذتوا فكرة عن الكورس. okay طيب so let us first cover the material which yes Noor you can ask. Can you do I need to unmute you, or why we cannot why can't we postpone the presentation a bit? I need to collect grades for everybody منشان الرجسترار بدهم يشوفوا إذا مثلا الفورث year if he meets the graduation requirement or he has something يعني there are critical things that get calculated here where he may opt out for pass or require the grade in a course or require I don't know what calculations they do, so they requested us to try as soon as possible to put the grades for the graduating class. هلا أنا I want the majority of you to finish within next week, بس I don't know if the majority of you have exams next week, so we need to schedule it. You are 72 over 2 groups of 2, that's 35 groups. We need at least half an hour per group, so بدنا حسبون يعني. Okay, I can do a stretch of 10 groups a day to be fair to you, but maybe not more than that, so I need some time. If you have, I will put a doodle for you to pick the days, including weekends. And maybe some of you can do it earlier than others, so they can start earlier, and then you guys can start later. But I don't know how many exams you have next week, Noor. Are all your exams next week? Yes, we have till May 18. The registrar requires before that date the grades. And okay, so May 8 is towards the end of next week. I will put some dates into يعني بس okay يعني you can pick مثلا I will put including Saturday and Sunday if you can, or Monday after, but I don't want to push it towards the end and I need to deliver the grades, and there are always people who miss the examination and they are graduating and I have to go after them. So let me put a time that's suitable for me and you. Okay, Rashid سأل سؤال and you will be sending an email regarding this on Friday. Regarding this Friday, yes. So I have to send an email for Friday. I have to send an email about you being prepared for a concept which you can explain, and then about the main topics. Manuel is asking, can you send an email summarizing everything? Yes, I will do that. But I just wanted to make sure that you are good with the spirit of things. هلا we're going to switch to the main concept of today. So let me start drawing something. نحن أخذنا اليولر باث. Okay, and the Euler path says مثلا إذا for example أنا I have a NAND gate for PMOS transistors وحنرسم لهم NMOS counterparts, and we want to draw the Euler path. هيدي إذا قلنا هيدي A وهيدي B ونفس الشي فوق هيدي A وهيدي B. The Euler path tries to find a common path بين ال pull up وال pull down. يعني إذا بدنا نرسم هون ال Euler path حنشوف هون عندي A B وهون عندنا A B. طيب حنجي نرسم ال diffusion تاعون ال N and the diffusion of the P, and then we will draw two polylines in the order of the Euler path اللي هو بيروح من A ل B. Okay, and so this is A and this is B. Okay. طيب and we will try to label the nodes. So إذا قطعنا هون إذا بلشت الارrow this way, I'm starting from VDD. Okay, I'm going to the intermediate node which is the out Y, and then I'm going back to VDD. Okay, and then in the NMOS network I'm starting out هيدي intermediate node 1 وهيدي ground. So هيدا اللي بيحدو ground لكينا عندي intermediate node 1 وعندي الأوت هون، وهيدا الأوت I'm going to connect it by a metal wire ليوصل لل P بال N. Okay, طيب great. هلا if we want to look to study the delay, let us say we want to study the delay of the pull down path. يعني مثلا إذا جيت سألتكم knowing that this transistor has only considering the capacitance at the output node, and knowing that each transistor of the NMOS network has REQN equal 10 kilo ohms, okay, and that the W by R ratio for A is 2, and the W by L ratio for B is also 2. When the output, when the inputs are switching 98 to 1, calculate the TP high to low delay. Okay, if we are looking to find that, أول شغلة بدي طلعها هو إنه أنا بدي طلع لل AB resistance وبدي طلع على النود out الcapacitance. Okay, so let us insert another new slide and look how do we find the resistance for the pull down. So هلا أول شيء أنا عندي البول داون هو عبارة عن resistor A وعندي resistor B وهن موصولين على ال output node وعندي capacitance هون. هلا نرجع على previous slide نحكي عن ال capacitance شوي. RA حيكون هو REQN over W by L صح؟ ونفس الشيء REQN over W by LB حيكون كمان هو resistance of this one. So I know what is the resistance بين السورس node اللي عم بتجر الاوتبوت والاوتبوت node. بقي عندي بدي أعرف الكاباسيتنس قديش هو على هيدي النود. Let us look at a transistor. If I have A and this is the drain of A وهيدا contact وأنا موصلة عندي هيدا another transistor وهيدا transistor B and this is transistor A and this is the source of A and this is the drain of B. ما هن ال A B موصولين مع بعضهم هيك صح؟ هيدا الجراوند وهيدا الاوت. اوكي هلا عم بعطيكم نحن ما حنعوزها هاي بهيدا الاكزامبل بس let us just say assume that I am asking you to find the capacitance at node 1. This is the source of A here and this is the drain of B here. إذا أنا قلت لكم إنه كل ترانزستور عنده a certain capacitance CD per unit width, what you would do, you would say at node 1, okay, the capacitance is equal to CD times WA plus CD times WB. اوكي ليش؟ لأنه أنا إذا وصلت هيدي بهيدي بيكون عندي capacitance من السورس والدرين. إذا جيت اطلعت على رسمة الترانزستور دغري if you don't recollect this, the source is here, the drain is here, and I'm going to add up the capacitance from the diffusion capacitance from the two transistors. هلا في one little thing which is why we draw Euler path. If we look here at node 1, it is really shared node بين A و B باليولر باث. يعني أنا بدل ما أكون عم برسم الترانزستورز like this, I am really drawing the transistors. عندي shared diffusion هيك لنرسمه بالجرين. عندي shared diffusion وعم أجي أرسم فوق shared diffusion the gate of A and the gate of B. اوكي صفى هيدي النود 1 اللي هي in the middle, it is really source A and it is drain B. بس أنا ماني مضطرة أعملها 2LS تتكون قد 2 diffusions. أنا هون عم بعملها 1LS كأنها 1 diffusion. اوكي هلا في كاتش وحدة إنه بحالة اليولر باث the W for all NMOSes has to be the same, at least for us. So basically هيدي النود اللي هون بين any two gates هي 1 CDW. يعني بالنسبة لإلي alternately بهالstructure هيدي هي 1 CD ضرب الcommon W. ما بقى عم عد الترانزستورز مرتين لأنه حسب اليولر باث هيدي مذكورة مرة واحدة مبين الديفيوجن لإلها مرة. أوكي هلا بناخد another example. So this we call shared diffusion. هيدا بنسميه shared diffusion حسب اليولر باث وهيدا unshared. يعني هيدا كل ترانزستور عم يعمل لي contribution مرة بينما اللي تحت نطلع على اليولر path drawing and we try to follow it. So if I go back now, حدا عنده سؤال لحد هون توضح لكم شو الفرق بين الشيرد والunshared؟ Okay. طيب. I go up now to the Euler path drawing and I ask myself what is the capacitance at the output node. So what is the capacitance at the output node here for this structure? بيجي بتطلع على اليولر path and I check how many times it appears. Okay. So it took one shared diffusion in the P. So هيدي هي CD ضرب WP. okay, and plus it took one shared diffusion or one unshared, in this case diffusion in the N plus CD ضرب WN. Okay. So what happened is that the Euler path helped me reduce the capacitance at the output node. لأنه أنا إذا جيت أطلع على ال unshared part, if I want to see the unshared diffusion, I would have looked at node out and said I have WPB, WPA, and I have WNA. So the unshared, let me get rid of this. The unshared هيطلع عندي الكاباسيتنس على النود اوت هو سي دي ضرب WPB plus WPA plus WNA. اوكي، حدا عنده سؤال لحد هون؟ اوكي طيب great. Okay, so now we know how to get the capacitance. We can therefore look at the resistance, and the RC will give me the delay for the pull down path. Okay, so let us now go to the make a slide about the homework 5 question, and then if we still have time we can go into the continue the examples that we have here in the slides. So if we look at the question, it is giving me an expression. Yes, Johnny. So we have reduced one CDW from the PMOS network. Okay. So the question says, I'm copying the logic function here. Okay. The question says, consider a logic function y bar equal a, b, or c into e, f, or g, and find a common Euler path. Then it asks me to draw the schematic. It asks me about the stick diagram, about calculating, sizing the circuit, of course, and then about calculating the shared diffusion capacitance, then sizing the circuit and calculating the unshared diffusion at every node of the circuit. So نحن حنبلش بالshared unshared بالUeuler path ونحكي نشرح السايزنج through this question, and then we will talk about the sizing slides that appear here also in the lecture notes. So sizing is very similar to what you took in 311. So let me draw the pull up and the pull down network. Copy it from the solution, and then we can okay. Okay, so this is we draw the pull up and the pull down networks. We find the Euler path. So if you remember the Euler path, what we find here is that the common path is highlighted here. So it is E, F, G, and then B, A. So it's E, F, G, and then B, and then D, B, A, or C, B, A. Okay, and the same for the pull down network. We see that it is E, F, G, C, B, A. Okay, so this is as far as the Euler path is concerned. هلا إذا بدنا نيجي نطلع على ال Euler path drawn in the homework, and then I will come back to the sizing. We want to calculate the capacitance at every internal node. So let us look at, if we draw it, assume that you know how to draw it, and I think that you know how to draw it. أنا هلا أطلع بس على الكاباسيتنس على ال internal nodes for you, and we will calculate them together. Okay, so خلينا نشوف الكاباسيتنس على internal nodes. Okay. Yeah. Okay. So here I have connected the internal nodes. Let us look, for example, first at node out. So if we look at node out مثل الإكزامبل اللي عنا connects one shared diffusion in the NMOS and one shared diffusion in the PMOS. So هيدي حتطلع sorry مش to CD WCD ضرب WP plus WN. Okay. You can find internal nodes that share multiple diffusions via connection مثل ال1 بس بالPMOS. We can also find their counterparts internal nodes also in the NMOS. يعني بهالحالة node 4 أخذت 3 diffusions 2 unshared كانوا 1 shared. So بتطلع هي 3 CD WN على النود 4. Okay, so capacitance at node 4 تطلع 3 CdWn. Okay, طيب عمر is asking, had we chosen a different Euler path, yes, it would have affected the capacitance. يعني بهالحالة معظم الكاباسيتنس إجا على نود 4 مش على نود out مثلا. لو أخذنا شيء تاني كان طلع معنا شيء مختلف. هلا the next thing that we would like to look at is Anur. Okay, لا sorry, هذا your old question. Okay. Okay, so the next thing that we want to look at is now how do I size my transistors. So let us see how do we size the transistors. Okay, so نحن عندنا pull up network and the pull down network, and typically what we learned in 311 is that to size the transistor we pick first the longest path بين output و ground أو بين output و VDD. Okay, so بين output و ground the longest path is 1, 2, 3, 4. هيدا 4 sizing. بما أنه the longest path is 4 transistors, then نحن تذكرنا إذا تذكرتوا NAND 4 إذا أنا am sizing relative to the inverter يلي هو P و N. Okay, and this was 2W and this was W. Then, and this is between output and the ground in the inverter. Okay, إذا أنا أطول شيء عندي stack of 4, all of these will be sized as 4W. Okay, so هيدا الباس كله حينحط 4W. Okay, so this will be 4W, 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 and 4W. Or we will say that 1 over WB plus 1 over WA plus 1 WE plus 1 over WF equal 1 على W, and we resolve them first to be all equal. And then what we can do is to now to find the other passes that have not been resolved. For example, I have another path من C مارق ب E و F. Either since this is parallel لل A will be بحذر أنا إنه هو حيكون قد نصهم 2 if you still remember, or what I can do is just write that I want 1 over C plus 1 over E plus 1 over F equals to 1 over W. okay, لأن هيدا هو another path. يعني عم نعمل كل single out to ground path يعني ما فيهم parallel transistor يعطوني نفس resistance تاعون الانفرتر. okay, we start first with the longest one. هو معي إياهم 4 و 4W, so I can now solve for the for C. okay, so بيطلع عنا C هي 2W. okay, now in a similar fashion what we have here is that I need to find G فيني لاقيها يا أما through C or through the fact that it is parallel to the other two transistors اللي هن 4 بعرفها أنها 2. يعني يا باخد هيدا الباس وبحللها يا بعرفها أنها مجبورة تكون parallel قد هو 2 حتطلع يعني 1 على 4 plus 1 على 4 equal 1 على 2. أو through كمان this path, whichever way it will give me the same answer. So فيني أقول 1 على C plus 1 على G equal to 1 over W. Okay, so let me read Johnny's question. Johnny is asking longest path according to the largest number of transistors. Yes, أكتر عدد transistor I'm going to visit between output and ground in a single path بدون ما أرجع أعمل loops هو بيمثل لي longest path. And I think this is because we end up having a smaller area of the design. هلا بالنسبة لل PMOS network I will do the same. So for the PMOS network, I will also look at the longest path بين VDD والout. Okay, and in this case, I have too much symmetry, so the longest path is really 2 transistors, and so I have 1 على B plus 1 على C. بس هالمرة بدهم يطلعوا بيساوي السايز لل PMOS device يلي هي كنا رسمناها نحن قبل. البيموس أخذناها بالإنفرتر هي 2W. أوكي so هو بدهم يطلعوا بيساووا البيموس of the inverter اللي هي 2W. I resolve them equally so بتطلع هيدي بدها تكون 4W وهي كمان بدها تكون 4W. Now by symmetry I can resolve that this should be 4W لأنه parallel devices and also the structure is similar so بيطلعوا كلهم بيساووا 4W as you have seen in the homework question. Okay. حدا عنده سؤال على هلا حنمرق على another example of the sizing which is in the lecture notes. But first, before that, I just want to calculate for you now what is the capacitance which is unshared at the output node. Okay, so if we want to look at the capacitance that is not shared at the output node, عندي node out موصولة فعليا ب different transistors يعني هي بالبي network موصولة ب C وب G وبال N network it is connected to B and C. Okay. فإذا if I want to calculate the capacitance for the unshared diffusion I will have to say that the unshared diffusion capacitance is really CD into بدي أحط W بالP تاعون C وال W بالP of G. In my drawing, in a differential path, it will be different plus WNB plus WNC. And حسب السايزنج اللي نحن اخترناه بيطلع ال unshared diffusion capacitors. So unshared is the worst option and this is why we draw the Euler path so that the gate is compact and the capacitance is minimized. بينما قبل هلا يعني the previously انجبرنا ب 1W for P and 1W for N but we ended up taking 2 shared diffusions. It is more regular circuit. Here they have different W's but so the delay can be maybe made more similar to the inverter in the worst case but the capacitance is intrinsic capacitance is higher. Okay. طب هلا حنطلع نرجع من هون. So this is the question mainly that is being asked in the homework. We will go now from here to the lecture notes slides. First I'm going to go over the sizing, okay, and then I will talk about the NAND gate in the end. So on slide number 21 we have a logic gate which is D or A into B or C. And he's telling me we want to size it after the inverter where Wn equals to 1 and Wp equals to 2. And we start by looking at the pull down network. هذا الأوت هون بس تخلص ال pull up بس يخلص كل ال PMOSes. So in this case the longest path number of transistors is 2. And therefore 1 على A plus 1 على C is equal to 1 على 1 اللي هو للأنموس. And since this is the first time I can resolve them to be equal وبيطلع معي إنه هيدي لازم تكون 2 هيدي لازم تكون 2. Now by symmetry I don't know if I'm rushing but I think you are all You remember this, right? Okay. And by symmetry, this will be 2 لأنها parallel لل C. And then this is a single path, so بده يكون نفس السايز تاعون الانفرتر transistor, so it is 1. For the pull-up network, I will look at the longest path. In this scenario, the longest path with 3 transistors. So بده يكون 1 على B plus 1 على C plus 1 على D is equal to 1 على WP يلي هو 1 على 2. We resolve them to be equal. بما إنه stack of 3 حيصيروا 6 6 and 6. Okay. For A, to find what's the proper value of A, I will either take this path وحيصير عندي 1 على 6 plus 1 على A equal ل 1 على WP اللي هي 1 على 2, or I will just resolve it by the fact that this is parallel to those two, فهي حتكون بتساوي 3. Okay, so either way, whatever you prefer or know how to handle faster, you can do that. But if you're confused, always resort to the equation that width in series is really the parallel of the width to transistor in series. We get the parallel of the width. Hello. Let me see if we have another. Okay, so this is another example here where we are now sizing it, but here I think they put the solution for us. Yeah, and then we have another example where we can size it the opposite. Okay, so فإذا هون نحن sorry عم تمشي المواصلة. Okay, bear with me 1 minute. Okay, so هلا بالقبل طلعنا عليها كانوا 3 6 6 6. هلا what if I start the network the opposite way? What if I start from this path? Then I will have 1 على A plus 1 على D equal 1 على WP اللي هو 1 على 2. So I will resolve them equally. I will get A4 and A4. Okay, now if I want to resolve B and C, it will be 1 على B plus 1 على C plus 1 على D equals 1 over 2. D I know it, and if I resolve B and C equally بيطلع بيساوي 8 and 8. أو if I resolve them from A بدهم يكونوا double it. Okay, so as you look here, the area إذا بنجمعها 8 8 و 4, it will be the transistors will be sized maybe larger, slightly larger than the transistors in the previous combination. هلا pull down network ما تأثرت لأن ال1 حتصير 2, so it depends really on that. But both ways are legal ways. We look for the one that has smaller area always. Okay, anybody has a question about the sizing? طيب, the Zoom will log out. I will log in again to explain the Elmore delay within the NAND gate. Tim, why we don't start with the N block? We do size them separately. So the N لحالة وال P لحالة we size them. Okay, so you can start with whatever one you want. لأنه طبعا ال N referred لل WN will P referred لل WP. Okay, بس هون I skipped it لأنه ال P اختلفت. Okay. هلا let us look at this example of the NAND gate here.